Hey guys, today we're going to talk about magnets, and magnets are pretty easy to understand because we've already talked about protons and electrons and the way they are attracted to one another and the electric field they have around them. Magnets are really similar. Magnets have a north and a south pole, and they have a magnetic field instead. So a lot of these things that we're going to be talking about today, they're very similar to what we've already talked about when we've talked about protons and electrons and electricity. They kind of work well together. So let's see what we have to say about magnets. So magnets, they exert forces on objects made of magnetic materials. So they're attracted to iron, nickel, and cobalt are our three materials that are going to be attracted to magnets. On a magnet, you have a north and a south pole. And if you take two north poles and put them near each other, they're going to repel each other. And if you take a north pole and a south pole near each other, they're going to be attracted to one another. So this is real similar to when we talked about if you have two protons next to each other, they repel, or two electrons repel, versus a proton and electron, which would attract. So it's the same idea. Likes repel each other and opposites attract. So just like with a proton or electron, how they have an electric field, a magnet has a magnetic field. And it surrounds every magnet and exerts a force on other magnets. So you don't have to necessarily have the magnets touching one another in order for them to affect each other. So if you bring two magnets close to each other, you guys have probably done this on a table before where you've kind of chased them around and there's a little gap between, and it seems to be this invisible force pushing them, but it's not. It's the magnetic field, and it surrounds the magnet in all directions. And so by the south pole you have that force, and by the north pole you have that force. So if you bring another magnet near it, it will either repel or attract depending on which pole you have facing out. So in order for something to be magnetic, it has to contain those three things that I talked about earlier. It's got to have iron, nickel, or cobalt, and those are affected by the magnetic field. So if you have a magnet and you bring it towards an object that has iron, nickel, or cobalt in it, it's going to be attracted to it. They're going to have that magnetic connection. And a magnet itself, the reason why that is magnetic is because its atoms are magnetic. It actually has a little north pole and a little south pole. And so that is the way it is made, and all those north and south poles of the tiny atoms add up together to make a strong force, which is why a magnet works the way it does. So normally magnets kind of have their poles kind of all scattered around, and the north and the south don't exactly go the same way. They're kind of organized in a chaotic form. In a magnetic domain, that's when you have atoms that have their magnetic poles aligned all in the same direction. So all the norths are pointing the same way and all the souths are pointing the same way. And this creates a pretty powerful charge because they're all working together as opposed to pushing and pulling against each other. And also in a permanent magnet, something that will always be magnetic, you're going to have everything's going to line up with each other and do a good job of being able to pull in those magnetic materials that it needs. And so we use permanent magnets for lots of stuff. I'm sure you guys have permanent magnets on your refrigerator. They use them in power plants, which we'll talk a little bit about next week. And they're a useful item, and the more they work together, the more their domains line up. In other words, the more you get the norths pointing all one direction and the souths pointing another, the stronger the magnet is. So I've got a little clip here of Bill Nye. We're going to watch a little bit of this and talk about this. This is just really good information and kind of explains things in a fun way. So check this out.
Hello, young neighbors. Welcome to Junior Science. Today we're going to talk about the mysterious power of magnetism.
This is a magnet, and this is a magnet.
Magnets are in places you might not expect.
Now, today we're going to have a lot of fun with magnets, and you can too, right at home.
Some of them are repulsive. Some of them are attractive. Some of them are... whoa!
Just another way in which science is used to make life better for all of us.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
property of matter.
Bill are the science guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by Farm Magnets. You get 2 poles in every bite. Magnetism. Magnets. You know, magnets stick to some things, like laboratory doors. Pretty nice decorations, huh? Magnetism is invisible. Magnetism comes from minerals found in the Earth. And the Earth is so full of these minerals that the Earth itself is a giant magnet. That's what makes compasses point north. A compass is just a magnet that's free to move. Now, the most common mineral that can be made into a magnet is iron. Right here is some iron powder, and this is a magnet. Watch. The magnet makes the iron powder form these lines, and we call that a magnetic field. Now, only 3 things can stick to a magnet: iron, nickel, and cobalt. Nothing else will stick. Not rubber dinosaurs, aluminum, silver or copper coins, gold jewelry, but iron sticks great. Now, magnetism comes from moving electrons. You know what we call moving electrons? No. Call it electricity. Now, where would we get some electricity? Well, how about from this battery? Now, when I connect this battery, electricity will flow through this coil, and we'll get magnetism. Here we go. Watch. There's enough magnetism to hold up all this weight. Now, what will happen when we disconnect the wire? Well, the magnetism will stop. You ready?
Sure.
3,
1,000.
2,
1,000.
1.
1,000.
Magnetism is pretty cool.
Jimmy is going to make an electromagnet at home. All he needs is a nail, some thin cloth-covered wire, and a dry cell battery. He wraps the wire carefully around the nail. Now he connects the ends of the wire to the 2 posts of the dry cell. Then he touches the nail to the clips. They hang on in bunches. Jimmy has made an electromagnet.
You live on a magnet. That's right, the Earth is a big magnet. That's what makes a compass work, even way up here. Now, where does the Earth's magnetic field come from? I mean, where are the moving electrons? Well, the Earth is full of melted iron and nickel, and the spin of the Earth makes the electrons flow in huge loops. The Earth's magnetic field extends way out into space. It goes right through the air and water. Spawning fish, migrating birds, and helicopter pilots all use it to find their way anywhere on the Earth. The Earth is a big magnet, and its magnetic field is pretty handy.
I am Martin the Magnificent. Watch as I make these ordinary paper clips disappear. Yes. It's not really magic. It's science.
That's my boy!
Magnets are made of metals: iron, cobalt, or nickel. If a magnet comes near one of these metals, it pulls on it. If a magnet comes near another magnet, it pushes on it or pulls on it. With magnets, likes repel, opposites attract.
Electrons in iron are spinning. Now, on a piece of iron like this, the electrons are spinning all different directions. But in a magnet that's made of iron, the electrons are all lined up, so that a magnet has a front end and a back end, a north pole and a south pole. Now, what would happen if you could cut a magnet in half? Would you get a magnet that was only a north pole or a magnet that was only a south pole? Well, take a look at this. These are the electron cars of science. They each have a front end and a back end, a north end and a south end. Now, right now, they're parked all which way. But let's line them up like the electrons in a magnet.
This is that magnetic domain idea,
Okay, Sally.
where everything's pointing the same direction, gives them more strength.
There. Now, let's cut them in half. See, we end up with two smaller magnets. These cars have a north end and a south end, a north pole and a south pole. So if you break a magnet in half, you get two smaller magnets that each have a north pole and a south pole. Near as we can tell, there's no way to get a magnet with just one pole.
Careful. Coming soon to a theater near you, Bill Nye the Science Guy as Compass Man. Follow Bill and his trusty compass as he searches for truth, justice, and magnetic north.
Look, it's Compass Man. Will he ever find his way?
Not him again.
He'll take you in directions you've only imagined. Compelling, repelling, and attractive. It's Compass Man. In thrilling Magnovision.
Jack is hanging a bar magnet by a string to see if he can learn more about this strange force. Poles that are alike push away from each other. Poles that are not alike pull toward each other.
Alright guys, so that's just kind of a basic idea about magnets. We're going to do lots of stuff in class with them. I'll let you guys play around with them. I'm sure you guys have done it before where you've pushed them around, maybe flipped them around on a pencil and watched them bounce, things like that. We're going to do all that. Don't forget the quiz on the back. Take your time. You guys have a great night. I'll see you tomorrow.